Hello students, welcome to this session. This is an introductory session on database management systems. Being the first session, I will be introducing you the concepts underlying with the database management systems. Currently, more than at any previous time, the success of an organization depends on its ability to acquire accurate and timely information about its operations, to manage them efficiently and use the data to analyze and guide its activities. So, the important aspect for any organization is the accurate data that it possesses and the efficient way that it retrieves the data whenever there is a need. So, all the organizations currently are moving to automation, wherein which the back-end part, the databases part plays a major role. So, in this course we will introduce you through the concepts of database management systems, and then along with this theoretical aspects of the database management systems, we will have the lab kind of sessions for the MySQL and the MS Access. So, what is a database? A database is a collection of related information stored in a computer so that it is available to many users for different purposes. So, starting with an example, let us take the case of a university. In the university, there are several entities interacting. One are the students, the faculty, courses, classrooms, library, canteen, hostels. So, there are several things, several entities we have. So, collecting the related information of all these entities and storing them in the computer, so that whenever there is an availability, we can retrieve the data, we can retrieve the information, or we can use that particular information for the better efficient functioning of the university. The content of the database is obtaining by combining various data. Suppose whenever there is a class, so who are the students attending the class, who is the professor taking that particular class, and which class is going on, which session is going on, all this information is related to that particular discussion. So, all the relevant information, relevant data are available to the users, and redundant data can be eliminated or at least minimized. So, there are several applications we can quote over here for the databases currently. The database holds recorded data. It may be of textual form, it may be of graphics form, it may be of images form, it may be of date and date, etc. Even the binary data also can be stored. It is an essential component of all information storage and retrieval systems. A database can be used simultaneously by more than one user and from different locations. So, let us see the visual over here. Here the database management system is nothing but the collection of interrelated data. Suppose if you take the case of university, the interrelated data, the interrelated entities we had talked about, like the students, the faculty, courses, hostel, classrooms, and the lab support, everything is interlinked, and that data we can keep it under one particular umbrella in one particular DBMS, which maintains, manages, and which gives you the information about that particular interrelated data of the university. The collection of data should be protected, should be secured. The collection of data, usually referred to as the database, contains information relevant to that enterprise. Here I had given you the example of an university. Likewise, it may be any office, a library, or else a railway reservation system, anything. The collection of that particular data relevant to that particular enterprise can be quoted as a database to that particular organization. So, here you can see, here the data is there at the back end, and this particular data is being managed by software called as database management system, which is a group of programs managing the data. And here on the top, the application layer is there. So, the several applications are interacting with the database management system. In turn, that database management system is using the back-end data that is stored. So, this is how the complete architecture of the database management system is laid down. So, depending upon the data, we have several applications we can design. So, several interfaces can be created. So, depending upon the data that we had stored, we can access, we can retrieve, we can store, we can take the printouts in the form of reports, we can visualize the data in various forms just like bar charts, graphs, etc. So, all these things are being possible whenever we have relevant data or interrelated data in place. So, the data that we are keeping in the end is called as the backend, and the application part comes as the front end. So, the front end application or else the user interfaces will access the data, and depending upon the requirements of the user, it displays the information by retrieving from the databases. So, what is the goal of a DBMS? So, this database management system, the primary goal is to provide a way to store and retrieve database information that is both convenient and efficient for the use of the user. So, two things are happening over here. One is the storing part and the other is the retrieving part of the data from the database. So, both the things are happening using this program called as the database management system. So, for what reasons we are storing and for what reasons we are retrieving? It is better, it is with the convenient and the efficient use by the user in order to provide the information to the organization. So, let us see the functions of the DBMS. Database systems are designed to manage large bodies of information. Suppose if you have information partly stored in the form of textual files, there are many files, and in that particular file you had created several tables, or else one particular file you had created the complete email addresses. In the other document you had created the mobile numbers of persons. Likewise, there are whole soul of textual data lying over there in the form of several documents. Managing that particular data is impossible. Whenever you want some certain information, crossover information from all the documents, it is next to impossible. Suppose if that particular interrelated data is being maintained as a part of DBMS, in the form of DBMS, then it is very easy to retrieve, even though there are several tables or several components, several data tables involved. Even then from those particular tables we can retrieve the meaningful information as per the requirements of the user. Management of the data involves both defining the structures for storage of information and providing mechanisms for the manipulation of information. So, there should be a way out wherein which we have to define the structure. This is just not like a textual file. Here you have to mention the structure of the table or mention the structure of the data table. Then you have to store the information in a meaningful way in order to retrieve using any structured query language. So, manipulation should be allowed, or else the updation should be allowed, deletion should be allowed, or else dropping the table or dropping the data should be allowed. All kinds of facilities should be allowed to work with that particular DBMS. Until and unless it provides a convenient and efficient use of that particular DBMS, we can't call it as a complete or pure database management system. Even when you take the case of a document, it is solving you to some extent. However, whenever you are keeping it under the umbrella of a DBMS, it is giving you meaningful, convenience and efficient use of that particular information. It should provide an interface also. In order to get the information stored in the databases, it should allow you to give some sort of interfaces wherein which meaningfully after putting a query, the information needs to be displayed or needs to be printed. So, validation, it should allow to analyze data requests and other things. Query optimization should be allowed. So, these are some of the functions of the DBMS, the interface part, the formatting and presentation part, the data security part and the backing up of all the data. Whenever there are failures, recovery of the data, then administering the whole databases, controlling the concurrencies. Whenever there are several users want the same information and same table, then the concurrency mechanisms needs to be in place and that will be managed by the DBMS. The transaction management is another function of the DBMS. So, there are whole plethora of functions that needs to be taken care by the DBMS, which manually we can't do. So, this is a complete automated process. Once the DBMS is in place, then all these functionalities are possible. Then let us see the applications part where we are using these database systems. Whenever we are going to the bank for withdrawing some money, what we will do? First of all, we will take a slip of withdrawal form, then we will fill the details. Along with the passbook, we present the withdrawal form. There the person on the other end receives the form, he verifies the information against the database, he verifies the signature, he verifies whether you are possessing the amount whatever you are asking for, he verifies the signature, he verifies the photograph. So, there were several things are possible within no time. After receiving the form, he immediately looks into the account number, he puts that particular number just like a query and he will get the whole lot of information on his screen so that he can verify and he can allow the transaction to happen. So, this is possible only when the data of that particular customer is stored at the back end. Otherwise, it is impossible for each and every customer whoever comes verification or verifying all the books or ledgers is next to impossible nowadays. So, he is having the data, he is verifying the data and he is allowing the person to carry on the transactions within no time. So, likewise airline reservation, whenever we reserve the tickets on flights, reservations, looking into the schedules or else postponing or else cancellations, all these things are possible. For universities, we are using the database applications. For student information, course registrations, evaluations, certifications, for all these things we are using the database applications. For credit card transactions, we are using the database applications. For e-commerce, nowadays everybody is doing online shopping. Nobody wants to waste time on going physically to visit a shop and purchase the products. So, all the possible like all the e-commerce transactions are possible nowadays. By sitting on the system we can do the e-commerce, we can purchase the product, we can cancel the product or we can see the details of any product. So, this is one of the database system application. And coming to the libraries for books information, members information, transactions and how many journals you have in that particular library, how many books are there, whether the book is available or not. So many queries we can put in the libraries also and within no time you can receive the information from the back-end databases. Telecommunications, this is one of the best application, one of the greatest application that we have for keeping up of records of all the calls that we make, generating the monthly bills, the prepaid, the postpaid, maintaining the balances, then the net balance, everything is possible using this particular back-end data. The financial applications, the insurance applications, what not, there are several database applications, whatever you say it relates to some sort of data at the back-end. So, all these applications are possible only if the interrelated data are being maintained by that particular company. Sales, online retailers, manufacturing. So for each and every branch you find the database application involved in that. Then comes the disadvantages with the file processing approach. Earlier we used to have the file processing approach. Why we are having disadvantages with the file processing approach? It is because of the data redundancy. Many places we are storing the same data, and suppose if we want to access that data, we will be in a great confusion. Otherwise, for each and every file that we have to write a program to retrieve the data. Suppose if the same data is being maintained in several files, updation is also very difficult. So updating the field on one file, and the relevant same field, if it is appearing in the second file, updating that particular field is a great difficult task. And when we compared this file processing approach with the DBMS approach, the greatest advantage that we are getting is the data independence. No need of changing the user interface program, no need of changing the data, only we have to look into the interfaces, we have to design the interfaces, what data that we have to retrieve. Otherwise, in the file processing approach, for each and every thing we have to write a complexity program in order to retrieve the data. The other thing with the file processing, disadvantage with the file processing approach is the data isolation. We have data, but it is lying in isolation. We have to gather, we have to see which data is there in that particular file, and we have to write a program. And sometimes it is very tedious and even impossible to write those particular complexity programs. For each and every change, we have to modify the program as well. You have the integrity problem, you have the atomicity problem, and then concurrent access anomalies. Sometimes it may allow, sometimes it may not be allowed when we are using the file processing approach. Obviously, security and protection problems will be there whenever we use the file processing approach. So that is why we right now are heading to the DBMS approach. In the DBMS approach, you have the data access part, data independence part, data security and protection. So each and every aspect, whatever the disadvantage that we observed in the file based approach, all those disadvantages are being overcome in the database approach. So data is regarded as an important resource over here. So every interrelated data, we are taking it and keeping it under the single umbrella. Whenever we want to have that particular data, we are putting a query and we are retrieving the data as well. So it provides a consistent and compact view of all the organization's data related to all the user departments. So we are compiling, suppose if you have several departments in an organization, and if we are following the file based approach, then it is next to impossible. Only one department people, they will be doing writing the programs depending upon the department's data and other things. Suppose if there comes a kind of requirement wherein which the information needs to be retrieved from different departments using the file approach, it is very tedious task. Then let us see the data abstraction in the DBMS. A major purpose of a database system is to provide users with an abstract view of data. It means that the system hides certain details of how the data is stored and maintained. When we talk about the file based approach, each and every minute knowledge is to be remembered. Which file contains what information, how many fields are there, like what is the data that it has, all these things we have to remember. But when it comes to the DBMS, a high level abstraction is there. No need to go into the details part, no need to, the system hides certain details, and we have to see only the design part and the storing part, not more than that. Or else what data is to be, what privileges of for the data is to be given to which user, only that part we have to see. So the complete data abstraction we can have using 3 levels. One is called as the physical level, the logical level and the view level. Let us see using a visual over here. One is the physical level. The lowest level of abstraction describes how the data are actually stored. So, it pertains to the access, like it pertains to the storage of the data, whether it is on the hard disk, whether it is on the tape, those particular things are being described in the physical level. It describes complex low level data structures in detail. So, this is the aspect that we have to see at the physical level. Then comes the logical level. Next higher level of abstraction describes what data are stored in the database and what relationships exist among the data. These particular things we see in the logical level. Earlier one, it was the storage, and this one, it is in the logical level we have to see only the what data is stored in the database and what are the existing relationships. That part only we have to take care. Next comes the view level. This view level is nothing but the user level. This is highest level of abstraction. The highest level of abstraction wherein which the view level of abstraction exists to simplify the user interaction with the system. The system may provide many views to various users. So, suppose if there are various levels of people working in various roles. So, for each and every role you can describe what is the view level. Data entry operator, what is the view level. For a manager, what is the view level. For the CEO, what is the view level. So, all these things can be have the abstraction at the view level. This is the figure for the data abstraction. The lowest thing, this is the physical level, it talks about the storage part. In the logical level, it talks about what data is being stored, and in the third view level, this pertains to the user. This is the next thing, wherein which the physical schema or the storage part is over here. The actual what data, what is the description, the schema, logical schema is over here. For the student table, student ID, student name and project ID are stored over here, and then it defines in the view levels, it defines the views for various users. Then comes the instances and the schemas. Databases change over a period of time as information is inserted and deleted. So, currently if I am having some 7 tables and with some data in it, so over a period of time, whenever the database grows during the period of time, the instance we can call is a snapshot. Snapshot means at any particular moment, suppose if we observe and if we record, that particular moment is called as the instant of the database. It is nothing but we are taking a snapshot. In this instance, this is the data we have. At this point of time, the data that we have is called as an instance. The overall design of the database is called as the database schema, the complete description. Suppose for example, if you take the case of a student table. So, how to define that particular schema? For table you can define the schema. For the whole database, for the complete tables, suppose if that particular university database is having some 7 tables or 8 tables, all that particular 8 tables design, description of each and every table is called as the database schema. For example, let us take, I had put the name university for my database. In that I have the student table. In that student table I am taking student ID, student name, student enrollment number, address 1, address 2, pin code, state. And later on I have another table in the same database, that is the faculty table, wherein which I am taking faculty ID, faculty name, department and then course likewise. Likewise, there are 7 or 8 tables. So, the description part is called as the database schema, and the whole set of interrelated tables is called as the database. Database systems have several schemas partitioned according to the levels of abstraction. Suppose if the schema, if we are designing it for the physical level, it is called as the physical schema, and the logical abstraction, that is called as the logical schema, and for the view level it is called as the sub schema. So, here we can see one example, a part, then customer, then there is another interrelated table. Here this particular description is called as the schema, the part number, part name, product, price and city. Then in the second table with name C, customer number, customer name, address and then city. And in PC you have part number, customer number and city. So this is how particular database looks like. Here it has 3 tables, each table is having its own schema, and then the complete 3 table schema is called as the database schema. So before winding up this particular session, let us recap. In this session we had introduced the database management system, how this database management system is different from earlier file approached systems, and then we had seen some sort of a kind of glossary for the DBMS, how it is important, what is the DBMS abstract view. So these things we had touched upon. Thank you.